Hello Year 10 and welcome to Sequences Lesson 4. Today we're going to be looking at generating arithmetic sequences from the nth term, but we're going to start today's lesson by looking at the answers to yesterday. So first of all, you have this question about the patterns made from dots. So hopefully if we take a moment to just look at this pattern, if you exclude these 4 dots right here, you can see that you've got 3 here. And then if we exclude these 4 from pattern number 2, we've got 2 lots of 3. And then if we exclude these 4 from pattern number 3, we've got 3 lots of 3. So pattern number 4 will have these 4, and then we'll have 4 lots of 3 being added on every time as a sort of an arrowhead. So this is what pattern 4 should look like. How many dots are needed for pattern 15? Well, you can see from the mark scheme here that they will just accept you working out how many dots were in pattern 1, 2, 3 and 4 and then continuing on that arithmetic sequence by adding 3 every time. But a more sophisticated way to do that would be to work out either by analysing the pattern or from the first few terms of the sequence that the nth term is 3n add 4. And so you need to do 3 times 15 add 4. Which gives you 49. Okay, the next question was again sort of dots, but this time they call them counters, and we've got a slightly different pattern. If you exclude this one here on the left-hand side, we've got 4 in a sort of an on its side T shape, and that's what's being added each time. So pattern number 2, we've got 2 lots of 4 plus this extra one. Pattern number 3, we've got 3 lots of 4, 2, 3 plus this extra one. So pattern number 4 will have 4 lots of 4 plus the extra one. So the answer is over here. Right, then you had to complete the table. Now all you need to do, they've written down the number of counters for you in each pattern. So you then just need to look at the term-to-term rule and realise that you're adding 4 every time. And that gives you 17 and 21. Find an expression in terms of n for the number of counters in pattern n. So again, you've just worked out the term-to-term rule is 4n. So you know, the term-to-term rule is add 4. So you know it's going to be a 4n type of nth term. And then hopefully you can see that it's 1 more than the 4 times table every time. Failing that though, as I did a minute ago, you could do it by analysing the pattern. So 1 lot of 4, add an extra 1. 2 lots of 4, add an extra 1, 3 lots of 4, so it's the term number times by 4, add 1. Right, Habib has 50 counters and he wants to use as many of his counters as possible to make a pattern in the sequence. What is the greatest number of the pattern he can use? What is the number of the pattern he can use the greatest number of his counters? So what I did was I thought, okay, this is a sequence connected to the 4 times table because it's a 4n add 1. So how close to 50 can I get with my 4 times table but still be below 50 because I'm going to have to add 1? Well, I know that 48 is in the 4 times table. So if I do 4 times 12, I get 48. Add 1 gives me 49. So the 12th pattern is the last one that he can make. That's as far as he can get with 50 counters. Okay, question 3. We've got grey tiles and white tiles, similar to the example we had in the lesson, but this is a bit different because the grey ones are the ones sandwiched in between. So it's a nice easy pattern though, because the grey ones are just the same as the pattern number. So pattern number 3, we've got 3 grey tiles, and then we've got white tiles either side, so we've got twice as many as the pattern number for our white tiles. So pattern number 4 is, as you can see here in the mark scheme, pattern in the sequence has 10 grey squares. How many white squares does the pattern have? Well, the whites are always double the greys, so it must be 20. A pattern in the sequence has a total of 45 squares. How many grey squares does the pattern have? So the way I see this is as a pattern split into thirds. 2/3 are white and 1/3 is grey. So if I divide 45 by 3, I'll get 15. So my answer is 15. And then I need to explain. And again, it doesn't need to be a paragraph. You just need to say something like divide 45 by 3 or a third of the squares are grey, or something that just very briefly explains why you have come up with your answer. Okay, the final question was triangles and circles. Again, you're asked to draw pattern number 4, and you can see that what's been added every time is an extra triangle and then these 2 circles. So another triangle, 2 circles, then another triangle, 2 circles. And so for pattern 4, I need to take pattern 3, add a triangle, and then add 2 circles. So find the number of circles in pattern number 7. So again, you could work out that we've got 3, 5, 7, 9. So it's going up by 2 every time, so 2n, and it's always 1 more than the 2 times table. So we know it's 2n add 1. Or you can do that from the diagram, because we've got this extra circle here, and every time we've got 2. So 2 lots of 2, 3 lots of 2, 4 lots of 2, add this extra 1. So 2n add 1. So that means we need to do 2 times 7, which is 14, add 1, which gives us 15. You can also get the answer for this by just continuing to write out the sequence in numbers or the pattern drawn out, but it's going to take you a while to do that, but it will get you the marks. Jane says pattern number 17 has 36 circles. Jane is wrong. Explain why. Well, what we do know about the number of circles is that it's always odd, because we've always got 2 lots, add an extra 1. So 3, 5, 7, 9, and it's going to carry on adding 2 each time, always being odd. So I would say something like, it can't be 36 because every number in the sequence is an odd number. Okay, so today's lesson, generating sequences from the nth term formula. So I've got an example on the screen here. Find the first 5 terms of the sequence with nth term formula 3n add 7. So the first term in the sequence is 3 times 1 add 7, because remember, n is just whatever term number you need to work with. So if we want the first term, then n is 1. Second term will be 3 times 2 add 7. Third one, 3 times 3 add 7. Then we're going to have 3 times 4 add 7, and then 3 times 5 add 7. So then we've got to calculate these, remembering BIDMAS tells us to do the multiplication before the addition. So we're going to have 3 add 7, which is 10. 6 add 7, which is 13. 9 add 7, which is 16. 12 add 7, which is 19. And 15 add 7, which is 22. So these are the numbers which are forming my sequence. Useful little check is to say, well, if I know that my nth term formula has a 3n, then I know that my sequence is going up by 3 every time. So in the end, I should find that I'm going up by 3 every time, which I am. And so this is my answer. These are the first 5 terms in my sequence. Okay, next one. Find the first 5 terms of the sequence with nth term formula 4n subtract 10. So pause the video and I'd like you to have a go at this one, showing your full working. Okay, so for the first term, 4 times 1 subtract 10. Second, 4 times 2 subtract 10. 4 times 3 subtract 10. 4 times 4 subtract 10. And 4 times 5 subtract 10. Then I can work those out. 4 subtract 10 is negative 6. 8 subtract 10 is negative 2. 12 subtract 10 is 2. 16 subtract 10 is 6. And 20 subtract 10 is 10. Now again, I know because this is a 4n nth term, I know that this is going to go up in 4. So it's a useful check just to make sure my sequence is going up by 4 each time. And actually, as a sort of a slight trick, if you work out your first couple of terms, you can then just continue your sequence by adding 4, provided you've understood that that's what this is telling you. So there's my sequence. Okay, now this is slightly trickier because this time we're subtracting 3n, but I'd like you to pause the video and give this a go before I go through it. So Do this showing full working and then press play for the answers. Okay, so I think the key to getting this correct is to show full working. So the first term will be 15 subtract 3 times 1. Then the second, 15 subtract 3 times 2, and so on. Now I'm going to do this in stages. I'm going to work out the multiplication first. So 15 subtract 3, which is 12. 3 multiplied by 2 is 6, so 15 subtract 6 is 9. 15 subtract 9 is 6. 15 subtract 12 is 3. And 15 subtract 15 is 0. So when you look at this, you should already know that because we're subtracting 3n, that's going to be a decreasing sequence. And then it's going to be going down by 3 every time. So you can just check at the end that that is what's going on. And there is my sequence. Okay, so here's your work for today. You've got a few sequences there for you to generate the first 5 terms. And then question 2, you've got an nth term for a sequence, and you just have to find the specific terms that it asks for. So if you pause the video and do this in your maths book showing full working.